Hello everyone, let's go over functions and polynomial. We'll do a review for our exam. So the first one says subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. When you see this word from, it kind of switches the order. You would do it the other way around where you are saying that you're kind of like saying that I am taking $10 from I don't know, John, who has $20. So we're not going to do 10 minus 20. We will do 20 minus 10. So this is not the way to go. So we will start with 3x squared plus 8x minus 7 minus 5x squared plus 2x minus 11. And when that happens, we end up distributing an invisible 1 into the parentheses, and it alternates the sign for us. So we end up getting a negative 5x squared minus 2x plus 11. And for the first one, it's an invisible positive 1, so it doesn't really change anything for us. We leave it the way it is. Then we combine the like terms for us. These are the like terms, which means that they have the same variable with the same exact exponent. So for this one, this is x with an exponent of 1. And then the last term we are left over with is our constant. So here we go. We get negative 2x squared. And then we get a plus, no, 8 minus 2. Did I alternate the signs correctly? Yes, this is a plus, sorry, yes, 6x, and then negative 7 plus 11 will give us a 4. Okay. All right, and then we can go ahead and box our answers. The next one asks if x squared minus 1 is a one-to-one function. I would go ahead first graph it just to see what it looks like. Y equals clear x squared, x squared minus 1. And the graph looks like it's a parabola. So if I go ahead, plot this parabola for ourselves. Now, this parabola passes the vertical line test because it touches the vertical lines just once. Each vertical line is touching it just one. But if I do a horizontal line test, then no, it's not passing it because the horizontal line is touching it twice. So we will say no because, actually instead of because, we will say, oh, no. Passes the vertical line test but fails the horizontal line test, which means each x value does not have a unique y value. Okay, done. Now, let's take a look at the next one, which is solving for x, and I'm going to go ahead and distribute. That's our first step. 24x, 5 times 6 is 30. Plus 3 is equals to 20x minus 2. We can go ahead and combine the like terms first, which gives us a 33. Now we can do inverse operation. Plus 2, which gives us a 35, and 24x plus 35 is equal to 20x. And then we subtract the 24x on both sides. And please write down the x. Don't just do minus 24. We need to show that we are taking our variables. Divide by negative 4, divide by negative 4. Yes, it's going to be a decimal, but we are not afraid of decimals because we are in algebra 2. We're not afraid of decimals. Negative alpha y equals 35 divided by negative 4, which equals to x is equal to negative 8.75. Okay, cool. Let's move on to the following one, which I'm going to do with the calculator. Y equal, I'm going to put square root of x, oops. And then I have to do x to the power of 3 minus 1. So now the first thing I'm going to look for is h of 4, which is this second equation that I just worked with right now. So for the second equation, I'm going to look at the table. So on the table, h of 4 is equal to 63. So that would mean that g of 63, thinking too much ahead, is equal to just radical 63. We cannot have a negative number underneath the radical because that would give us an imaginary. So that is what we are thinking about when we are doing our domain. So we could do this also with the calculator. Here, let me show it to you. Why isn't it clearing? So square root of x minus 8. And if I look at the table, all of these numbers are giving us error, anything domain. So we're looking at x values. So x cannot be less than 8. Can it be exactly equal to 8? Yeah, it can. And another way we can also do it is like whatever is underneath the radical, we force it to make it greater than or equal to 0. And then we just solve for x. X has to be greater than or equal to 8. So the answer is option number 3. So that would mean x could be 10, x could be 12, but x cannot be 7, 6, 5, or 4. All right, so let's take a look at the next one. Number 6, we have where we do two functions, composition of function, kind of similar to number 4, but we're doing it with the graph and with like this little circle symbol instead of with the parentheses. So first we need to find g of 9. So g of 9 is right here, which is 2. So g of 9 is equal to 2. And then we would do f. We're going from right to left. So f of 2 is equal to, let's see, 1, 2. F of 2 is at looking like a 7. Yeah. Okay, cool. So the answer is 7. All right. Next one is asking us to do an inverse function. So for an inverse function, we need to, first things first, let me find out how I can change this x and y. So y is equal to x plus 8 is equal to 5x plus 2. So I turned, instead of the f of x, I wrote it as y, which is also fine. Then we switch our x and y values. So wherever I see y, I'm going to put an x. And wherever I see x, I'm going to do a y. So I'm just writing them all at first. And then I'm going to do the switcheroo plus 8. Okay, now my goal ends up being how to get this y by itself. And I know there are two y's, and sometimes that definitely gets a little bit tricky, but we got this. We got to get rid of the denominator by multiplying by 5y plus 2 on both sides. So it becomes x times 5y plus 2 is equal to y plus 8, which gives us 5xy plus 2x is equals to y plus 8. Now we need to get the y by itself and like all the y's together. So I am going to remove this 8, which gives us 5xy plus 2x minus 8. But we do have this other y also on the left side, so we got to take that situation to the right. So I'm going to do minus 5xy on both sides. Which leads us to 2x minus 8 is equals to y minus 5xy. We could fix it. I don't need the calculator right now. We could fix it by saying, let's see, we could do a GCF of y, which becomes 1 minus 5x, and on the left side it remains the same. And now we can divide our 1 minus 5x. Oh, that's a terrible looking 5. Let's fix that 5. So it's actually y is equal to 2x minus 8 over 1 minus 5x. Now, this 1 minus 5x, like if I wanted to, like I could switch it around, which would be negative 5x plus 1. Now, this is where we start to prepare for another unit. It's like, hey, if I pull out a GCF of 1, then it becomes 5x minus 1. Which is basically like taking this and just flipping the order and putting a negative on the outside. It happens time to time, so I think it's like better to start preparing for that next lesson that's coming up for us, just to, we remember. So it will be y is equals to 2x minus 8 over 5x minus 1, and I'll put the negative on the outside so we can see it. And if you want to go even way above and beyond, you could do y is equal to 2 and then x minus 4 over negative 5x minus 1. So this will be even better because everything is nicely factored out and boxed, and like the negative is in the front. All right, so for the next question, they're asking for our area, which is area is equal to length times width. Now, for this rectangle, we have a length and a width of this specific situation. So you would do area is equals to 3x plus 4 times x squared minus 3x minus 3. So I'm just going to go ahead and distribute. You can also do the box method. So I'm going to do the first distribution, which is 3x to the power of 3 minus 9x, and square, and then minus 9x. And then let's do another one, which is plus 4x squared minus 12x, and then again minus 12. And then we continue on by combining our like terms. This one doesn't have any. Let's see. This one and this one is looking good. And then the last one. Okay, the colors are a little bit same, but oh well. So we have 3x to the power of 3. Negative 9 plus 4 is negative 5x squared. And then negative 9 minus 12. I cannot do that by heart. I need a calculator for that. Oops. Let's see. Negative 9 minus 12 is equal to negative 21x, and then minus 12. And that's it for this question. Okay, let's move on to the next one. So the next ones are our 3x3 system. Now for the 3x3 system, we are going to first put it in the calculator. And for this is the only one that I'm going to show it with the calculator. The other one I'm going to let you do you. So the first step, and I always do it in the calculator first, just because like, just in case if I mess up my first variable, I know, like I know it in the answer, like, oh, this is the wrong answer. So I have to double check it again. First things first, I'm going to do second plus 712, reset my calculator. Then do second matrix. Let's go to edit. And this is a 3 by 4. And then I put in all my information. 4, enter, 4, enter, 1, enter, 24, enter, 2, negative 4, 1, 0, and then 5, -4, -5, and then 12. Okay, then I exit the screen by pressing second mode. Then I go back to my matrix again, math, and then ref, and then I put in my matrix again. Close it. Okay, that means I know when I solve it, I need to see a 4, 2, and 0. Okay, let's do this. This is our 1, 2, and 3. First, I'm going to do pair 1 and pair 3. 4x plus 4y plus z is equal to 24. Then I have 5x minus 4y. 5z is equal to 12. Let's add them up. We get a 9x minus 4z is equal to 36. Done. Let's do 1 and 2. 4x plus 4y plus z is equal to 24. And then we have 2x minus 4y plus z is equal to 0. If I keep going, I get a 6x plus 2z is equal to 24. Okay, done with one part. Now let's do the other one. 9x minus 4z is equal to 36. And then 6x plus 2z is equal to 24. Now this bottom one, if I multiply it by 2, we should be able to cancel out our z values. So we have 6x. Nope, not 6x anymore. My bad. 12x plus 4z is equal to 48. Then we have 9x minus 4z is equal to 36, which ends up giving me a 21x is equal to 84. X is equal to 4. Look, it matched. Perfect. Then I can keep going. I'm going to use this value of x to plug back into one of like these first two equation. I am going to plug into the bottom one because it like they're like smaller numbers. So that's the only reason I'm picking that. If you want to pick the top one, of course, go for it. 24 plus 2z is equal to 4. 2z is equal to 0. Z is equal to 0. Perfect. Worked out for the second one. Now let's do the last one. For the last one, you could pick any equation you want. I'm picking the one with 2x just because it has smaller number once again, which gives me a 2 times 4 minus 4y. Wait, why did I put a 0 there? Oh, because this was z, which we got the value is equal to 0. Okay, 8 minus 4y is equal to 0. I'm not putting the 0 again because it's not making or breaking it. So minus 8, negative 4y is equal to negative 8, y is equal to negative 2. And like I just like to like box them up nicely or like write them out all together. So it's like easier for like the grader to see that, ooh, this is the answer. This is supposed to be a positive 2. Let's fix that. Because negative divided by negative is a positive. So yeah, that's that. All right, so for the next one, I recommend like you pause it and then try to do it. So that way you could see the answer at the end. And I'm just going to start solving. Okay, I hope you had paused it. And then I'm doing it with my first and second pair, trying to cancel out my x values. Okay, negative y plus 3z is equals to negative 12. All right, let's do the other one. I'm going to do the second and the third. So this was my 1 and 2. So now I'm going to do 2 and 3. And like for this one, the reason I chose to like cancel out the x's, because I'm going to be a little lazy and just go here. Yes, because like our x's are already positive and negative. So I just went for it like, hey, these two cancel out. And then we are left with negative y plus 2z is equal to negative 8. All right, so now that I have these two, I can go with it. Negative y plus 3z is equal to negative 12. Negative y plus 2z is equal to negative 8. I'm going to multiply the bottom one with the negative 1 just so like I have a positive y, because we want to be able to add two of them and cancel it out, right? And right now both of them are negative. If I add them, I'll get a negative 2. Okay, so now we can cancel out. We get z is equal to negative 4. Perfect. We are going to use this to solve for our y values. Negative y, I'm just using the bottom equation. 2 times negative 4 is equal to negative 8. Negative y is equal to 0 because I added 8 on both sides. Divide by negative 1, y is equal to 0. Great, perfect. And then the last one, let's use a nice green. I'm using x plus 3y minus z is equal to 2. We're solving for x plus 3 times 0 minus negative 4 is equal to 2, which is x plus 0 plus 4 is equal to 2. X plus 4 is equal to 2. Minus 4, x is equal to negative 2. I'm going to write them all out together. X equals negative 2, y equals 0, z is equal to negative 4. Bam, that's our answer. And that's it for today. Make sure you copy down all the notes, and if you have any question, you could bring it to class.